In this tutorial, we're going to dive into designing a pipeline that leverages the power of generative AI models and integrates them seamlessly into the Fyrefuse platform. When incorporating GenAI into a pipeline, you generally have two options. You can either use an external model that is hosted remotely, which can be accessed via standard communication methods like REST APIs, or you can deploy a locally trained model that runs on on-premises machines. In this tutorial, we'll begin by exploring how to integrate a custom AI model into pipelines. Afterward, we'll build a Fyrefuse pipeline that uses the ChatGPT 4 turbo model to summarize locally stored PDF files. We'll begin by showing you how to import your own machine learning model into Fyrefuse as a UDF, a user-defined function. This allows you to integrate custom models or domain-specific logic directly into your data pipelines. For this example, we've provided a UDF bundle containing two components: a serialized version of a pre-trained machine learning model and a Python script that implements the UDF using PySpark's required syntax. Models can be serialized using tools like joblib, pickle, or other common serialization methods. It's important to note that Spark UDFs are applied individually to each record in the dataset. So, optimizing for performance and scalability is essential when designing these functions. To keep the focus on the core goal of this tutorial, we will cover the essential steps for integrating your model as a UDF. Though, if you're interested in exploring additional use cases and advanced functionality that can be implemented with UDFs, be sure to check out our other tutorial on implementing UDFs in Fyrefuse. Here is how you define your function. First, you specify the output type, which in our case is a string, or text in other words, and map it to the functionality itself. This approach is crucial because it allows Fyrefuse to integrate any Python code seamlessly. This flexibility is one of the key strengths of Fyrefuse, enabling you to incorporate complex logic, custom models, and specialized processes into your data pipelines. It's this adaptability that truly sets Fyrefuse apart, allowing users to extend its functionality beyond standard use cases and tailor it precisely to their needs. For this particular example, the model expects three inputs: the content to summarize, a temperature value that controls the randomness of the output, and the desired number of summaries. At the end of the function, we construct a pandas data frame to run the inference and generate the summaries. Another approach involves using a remotely hosted model as a service, integrating it into the pipeline. For example, if you wanted to integrate the ChatGPT model via OpenAI's API, the UDF would look something like this. While we won't dive deeply into this approach, it's important to note that the overall logic remains the same as the previous use case. The only difference is that the model is accessed remotely, rather than running locally. This UDF sends an HTTP request to OpenAI's API, passing all the predefined parameters, and returns the response as the output value. Now, let's walk through how the process of integrating this into Fyrefuse looks. First, navigate to the Jobs section from the sidebar menu. In the top right corner, you'll find a button with a plus icon. Click on that to create a new job. Enter a name and description, select Job as the category, and choose the repository where you'll store it. Finally, upload your implementation, and you're all set. As you can see, our UDF has already been added. Now, we can proceed to integrate it into the pipeline and start using it. Next, let's navigate to the Templates menu and select the template where you'd like to use the UDF. We'll start by building a pipeline that uses this UDF to summarize locally stored PDF files. The pipeline begins with a batch source node, which uses the NFS method to load all files matching the star.pdf pattern. Let's take a closer look at the schema to understand how this node operates. As you can see here, the node loads PDF files, and we have four main columns in the preview: the path of the files, the time of modification, the file length, which represents the file size, and the actual binary content of the file. Now, if we look at the path, it indicates the location of the files being read. For example, here we can see files stored under Home, Fyrefuse, PDFs, and the file name itself. The parent directory is defined in the repository, and if you're curious about how repositories are created, check out our tutorial on how to create a repository. At this stage, we can't directly use the binary data. It needs to be decoded in order to extract the textual content from the PDF files, which is essential for the AI model to understand and process the information. Additionally, there's a potential security concern. The file paths may contain sensitive information. Fyrefuse helps mitigate this by allowing all these operations to be performed effortlessly within a template. Moving on to the next node, we have the Anonymize node. Here, we use a regular expression to mask the file path up to the file name, replacing it with a placeholder like private for security reasons. This helps anonymize the data, ensuring that sensitive paths aren't exposed. Next, we need to process the binary contents. To do this, we import a special user-defined function that decodes the binary PDF content into actual readable text, which we can then summarize. Once we've imported the UDF, we apply it to the dataset using a SQL node. You'll see the schema here, showing the available input datasets and the resulting output dataset. The UDF generates an array of strings, each string representing the content of an individual page from the PDF. The next step involves pre-processing the data. Since the UDF outputs an array of strings, an element per page, we need to flatten or explode the array. Essentially, this means we take one row that contains 5 pages and transform it into 5 rows, each containing the content of a single page. We achieve this using Apache Spark's built-in SQL functions. After flattening, we end up with 2 key pieces of data, the page number and the content of that page. Now, let's focus on the upper flow, where we'll use the UDF we saw earlier to have ChatGPT summarize the pages. First, we import the UDF. This function requires a prompt and an OpenAI token to work. To set this up, we'll create 2 variables, one for the default prompt, which will be added as a prefix to each page, and another for the OpenAI token. Once we've set up the variables, we apply the UDF with the GPT implementation. This is done through another SQL node, where we select all the relevant columns and pass the input parameters into the GPT for UDF. If you're familiar with expression languages, this syntax should look familiar. Once the GPT model processes the text, we'll see the output column labeled GPT response, which contains the response in JSON format from the online GPT model. The actual summarized text is stored under the choices, message, and content keys. Finally, we define where we want to save the results. In this case, we'll save them into a data layer. After saving the pipeline, we can go ahead and run it to see the results. And that's it. We've now built a pipeline that utilizes a generative AI model to summarize PDF files while handling data securely and efficiently within Fyrefuse. Now, after the pipeline finishes its execution, we can go ahead and explore the data layer that we use to store the results generated by the GPT model. For that, we navigate to the Data Explorer menu. Click to open up the Query Builder wizard, then select Layers, and the layer that our pipeline was writing to is called AI. As you can see, we have 2 tables here, one for saving shorter pages and another one for saving summaries. If we click on this table, the Schema Selection panel opens up, where you can click each column to include it in the query. Now, we are interested in IDX, which represents the number of the page, the path, then the page content, which contains the actual text of the page, and finally the summarized text. You can run this query as it is and see the results. But for this tutorial, we have prepared a specific query that both makes the output easier to read and demonstrates the capabilities of Fyrefuse's Data Explorer. The underlying SQL dialect is Trino SQL, and you can take full advantage of its functionality. In this particular example, we simply renamed the columns and extracted the summary from the structured object returned by the GPT model. Then, let's go ahead and run the query. As you can see, the pipeline has successfully generated 94 results, with each entry representing a single page. To make it easier to explore these results, let's group them by file and page number. We've also added a column showing the model name that was used to generate the summaries. Because why not? It's always good to know which AI model worked its magic. The last column in the table displays the generated summaries. If we look at the first row and compare the summary to the original text, it reads, "The text is an example paper for authors preparing submissions to the UCENIX conference, utilizing an HTML, CSS template." Yep, that seems about right. You're more than welcome to continue exploring the results and build more advanced use cases using the tools available in Fyrefuse. This concludes the tutorial. We have demonstrated how to integrate generative AI into Fyrefuse, utilizing both external models and custom UDFs for tasks such as summarizing PDFs. We encourage you to explore and adapt these techniques to fit your specific needs. Thank you for following along.